You know, I want to tell you something that kept me awake for years, and perhaps tonight it will help you find the most peaceful sleep you've ever had. Imagine two particles, born together in a single moment, then separated by the entire width of the universe. You measure one, and instantly, faster than light itself could ever travel, the other particle knows. It responds. It changes, as if the universe itself is whispering secrets through invisible threads that connect everything, everywhere, all at once. This is quantum entanglement. And when I first understood what it truly meant, I felt my entire view of reality crack open like an egg. Everything I thought I knew about separation, about distance, about being alone in this vast cosmos, it all transformed. Because if two tiny particles that have never met, that are separated by billions upon billions of miles, can still be connected in ways that defy every intuitive sense we have about how the world works, then what does that say about you and me? What does that say about everyone you've ever loved, every hand you've ever held, every moment of connection you've felt but couldn't explain? Tonight, I'm going to share with you 100 calm, beautiful facts about quantum entanglement. But this isn't just about physics. This is about understanding that the universe is far stranger, far more intimate, and far more connected than you ever imagined. And as I walk you through these ideas, I want you to let them wash over you like waves. Some will excite your mind, some will confuse you, and that's perfectly fine. Some will lull you into the deepest, most restful sleep. Because science, real science, isn't just about knowing things. It's about feeling the universe breathe with you. So get comfortable. Close your eyes if you'd like. Let my voice be a companion in the darkness. And let's explore together this mysterious quantum dance that suggests we're all far less alone than we ever believed. When I was a younger man working at the patent office in Bern, I spent my days looking at other people's inventions, but my nights belonged to the universe. I would sit by candlelight, filling notebooks with equations that tried to capture something I felt in my bones but couldn't yet prove. I kept returning to this troubling question about light, about time, about the nature of reality itself. And the more I looked, the more I realized that everything we think we understand about cause and effect, about things being here or there, about the solid, dependable nature of the world, it was all a beautiful illusion. You see, we live our lives believing in separation. You are there, and I am here. The moon is far away in space. Your childhood is far away in time. But quantum entanglement whispers a different truth. It says that at the deepest level of reality, separation might be the real illusion. Connection might be what's fundamental, and that changes everything. Let me give you the first calm fact, and we'll let it sink in slowly, like honey dissolving in warm tea. Fact number 1 is simply this. Quantum entanglement means that two particles can share a connection so deep that measuring one instantly affects the other, no matter how far apart they are. Not almost instantly, not very quickly, instantly, zero delay. This bothered me so much, I called it spooky action at a distance, because it seemed to violate everything I knew about how the universe should work. According to my own theory of relativity, nothing can travel faster than light. No information, no signal, nothing. And yet, here was nature, seemingly breaking my own rules. But here's the beautiful part, the part that will help you sleep tonight with a smile on your face. The universe wasn't breaking rules. It was showing me that I hadn't understood the rules deeply enough. Quantum entanglement doesn't send signals faster than light. Instead, it reveals that at the quantum level, two particles that have interacted can become a single unified system. They're not two separate things communicating across distance. They're one thing that happens to be expressed in two different locations. Imagine that. One thing in two places at once. Think about this as you drift off to sleep. Every atom in your body was once inside a star. Those atoms were entangled with other atoms, scattered now across the cosmos. In some strange, beautiful way, you carry within you connections to everything that has ever existed. The iron in your blood was forged in a dying star billions of years ago. The calcium in your bones was created in stellar explosions. And at the quantum level, some of those particles might still share connections with particles in distant galaxies, invisible threads that tie you to the entire universe. Fact number 2. Entanglement is created when particles interact in specific ways. And once created, this connection persists regardless of distance. The most common way this happens is when two particles are created together from the same source. Picture a parent particle decaying into two children particles. Those children are born entangled, twin souls of the quantum world. They emerge into existence sharing a deep correlation. If one spins clockwise, the other must spin counterclockwise. If one has a particular energy, the other must have a complementary energy. They're like two sides of a single coin, forever linked by their origin. I remember explaining this to my colleagues, and they looked at me as if I'd lost my mind. "Albert," they'd say, "you're telling us that reality isn't real until we measure it? That particles exist in multiple states at once until we look at them? That's madness." And I understood their resistance because I felt it too. Everything in our everyday experience tells us that things have definite properties whether we observe them or not. The moon is there when nobody looks at it. Your coffee cup is on the table even when your eyes are closed. But at the quantum level, this common sense completely breaks down. Fact number 3. And this one is particularly soothing for a restless mind. Before measurement, entangled particles exist in what we call a superposition state. This means they simultaneously exist in all possible states at once, like a cosmic maybe, a universal perhaps, the particles spinning clockwise and counterclockwise at the same time, up and down, here and there. It's only when you measure one of them that the superposition collapses, and both particles suddenly have definite states, perfectly correlated with each other. This quantum maybe state is one of the most profound aspects of reality. It suggests that the universe is fundamentally probabilistic, not deterministic. The future isn't written in stone. It exists as a cloud of possibilities, and reality crystallizes into one specific outcome only when observed. This bothered me deeply for years. I spent countless nights arguing with Niels Bohr about whether God plays dice with the universe. I didn't want to believe it. I wanted the universe to be predictable, ordered, knowable. But the evidence kept pushing me toward this uncomfortable truth. At its deepest level, reality is mysterious, uncertain, and far more interesting than I'd hoped. Let that uncertainty comfort you tonight. You don't have to have everything figured out. The universe itself doesn't have everything figured out. Even at the level of atoms and particles, reality is feeling its way forward, exploring possibilities, collapsing into specific outcomes moment by moment. You're not failing when you don't know what comes next. You're participating in the fundamental nature of existence itself. Fact number 4. The measurement of one entangled particle doesn't cause a signal to travel to the other particle. Instead, the measurement reveals a correlation that already existed in the combined quantum state. This is subtle, but important. When I measure particle A and find it spinning clockwise, particle B doesn't receive a message saying, "Hey, you need to spin counterclockwise now." Rather, the act of measuring A collapses the shared quantum state they both inhabit, and when that state collapses, both particles simultaneously acquire definite complementary properties. It's like having two sealed envelopes, one containing the word left and one containing the word right. You send one envelope to Paris and keep one in New York. When you open the New York envelope and see left, you instantly know the Paris envelope contains right. No, signal traveled between the envelopes. The information was encoded in the system from the beginning. But here's where quantum mechanics gets weird. Before you opened either envelope, neither contained a definite word. They were both in superposition, somehow containing left and right simultaneously, until the moment of observation. This is why I found quantum mechanics so philosophically troubling. It seems to give observation, consciousness, the act of looking, a special role in creating reality. Before measurement, particles don't have definite properties, they have potential properties. Reality emerges from possibility through the act of observation. Does this mean consciousness creates reality? Does it mean the universe needs observers to exist? These questions haunted me then, and they remain mysterious now. Fact number 5. And you can feel your breathing slow as you consider this. Entanglement has been experimentally verified countless times across distances of hundreds of kilometers using photons, electrons, atoms, and even small molecules. This isn't speculation. This isn't science fiction. This is the verified, tested, confirmed nature of reality. Teams of scientists have sent entangled photons through fiber optic cables across entire cities. They've beamed them between islands. They've transmitted them to satellites in space, and every single time, the correlation holds. Measure one, and the other responds, perfectly synchronized, as if distance means nothing at all. I wish I could have lived to see these experiments, though I predicted them. I proposed tests that could distinguish between quantum entanglement and classical correlations. Other scientists refined these tests, particularly John Bell, who created mathematical inequalities that quantum mechanics violates but classical physics respects. When experimenters finally performed these tests decades after my death, quantum mechanics won decisively. The universe truly is entangled. Reality truly is non-local. And everything I found spooky and uncomfortable turned out to be beautifully, mysteriously true. Let that sink in as your body relaxes. The universe is provably stranger than common sense suggests. You live in a cosmos where connection transcends space, where particles communicate through means we still don't fully understand, where the very fabric of reality is woven with invisible threads that tie everything together. You are part of this quantum tapestry. Every particle in your body is potentially entangled with particles elsewhere in the universe. You are not a separate island of consciousness. You are a wave in an infinite ocean, distinct yet inseparable from the whole. Fact number 6. Entanglement applies not just to individual particles, but to systems of particles. You can entangle photons, electrons, atoms, even small molecules containing hundreds of atoms. Scientists have created entangled states in quantum computers involving dozens of quantum bits simultaneously. The more particles you entangle, the more complex and fragile the quantum state becomes, but the principle remains the same. What happens to one part of the system correlates with what happens to the other parts, regardless of the distance separating them. This scalability of entanglement raises a fascinating question that kept me up at night. If entanglement works for 2 particles, 3 particles, 100 particles, where does it stop? Why aren't we directly aware of quantum entanglement in our everyday lives? Why can't I entangle my mind with yours and know your thoughts instantly? The answer lies in something called decoherence, which we'll explore soon, but the question itself is beautiful. It suggests that the boundary between the quantum world and the classical world, between the realm of weird probability waves and the realm of solid definite objects, is not a sharp line but a gradual transition. Fact number 7, and feel your eyelids growing heavier. The quantum state of an entangled system cannot be described by describing each particle separately. You must describe the system as a whole. This seems like a technical detail, but it's actually profound. It means that entangled particles lose their individual identity. They become parts of a unified whole that cannot be broken down into independent components. The whole is genuinely more than the sum of its parts. The relationship between the particles becomes more fundamental than the particles themselves. Think about what this means for how we understand things. We're taught to understand complex systems by breaking them down into simpler parts. Want to understand a car? Study the engine, the transmission, the wheels, each component separately, then put your knowledge together. This reductionist approach has been incredibly successful in science, but quantum entanglement suggests there are limits to reductionism. Some systems cannot be understood by studying their parts in isolation because the parts don't have independent existence. The relationship, the connection, the entanglement itself is what's real and fundamental. Apply this to your own life. As you drift towards sleep, you cannot fully understand yourself by examining your thoughts, emotions, and experiences in isolation. You are a system entangled with other people, with your environment, with your past and future. The connections you share with loved ones aren't just nice additions to your independent existence. Those connections partially define who you are. When you lose someone close to you, you're not just losing an external relationship, you're losing a part of the entangled system that constitutes your identity. Grief hurts so much because it's not just loss, it's a kind of quantum collapse, a reduction of the entangled state that was you plus them into just you. You become less than you were because the whole really was greater than the sum of its parts. Fact number 8. The universe doesn't feel your pain, but it remembers your connections. You see, in quantum mechanics, there's something called quantum coherence. When two particles interact, they create correlations that persist even after they separate. The universe quite literally stores the history of their relationship in its fundamental structure. It's not metaphorical, it's measurable physics. When someone dies, the atoms that made up their body don't vanish. They scatter, yes, but every interaction they ever had with you left traces. Not just in your memory, in your neurons and synapses, but in the actual fabric of space-time. You warped each other's trajectories. You exchanged photons that altered electron states. You breathed air molecules that the other person had breathed. I used to think this was cold comfort, this idea that we're all just recycled stardust. But then I realized, if the atoms remember, if the universe stores every interaction, then nothing is truly lost. The information persists, the pattern that was them, the way they organized matter and energy that changed the universe permanently. Your grief is the echo of that change. It's the recognition that you were part of a larger system, and now you're trying to operate with missing components. Of course it hurts. You're detecting the absence of expected signals. Your whole being was calibrated to their presence. But here's what I want you to understand. The pain you feel is proportional to the connection you had. Deep grief is evidence of deep entanglement. The more it hurts, the more real it was. That's not a consolation, I know, but it's true. And the universe doesn't erase that truth just because one part of the system stopped functioning. The relationship you had bent space-time. It created ripples. Those ripples are still propagating outward, and they always will be. You are carrying forward a pattern that includes them. Every choice you make that was influenced by knowing them, every thought shaped by your time together, that's them still affecting the universe through you. Not metaphorically, causally. Fact number 9. The quantum vacuum isn't empty. It seethes with virtual particles popping in and out of existence. These aren't theoretical abstractions they create, measurable forces. The Casimir effect proves it. Place two metal plates close together in a vacuum, and they'll attract each other, pushed by the quantum foam itself. The space between them becomes more empty than empty space should be, and that difference creates pressure. Reality, at its foundation, refuses to sit still. You want to know what that means for your fear? Your anxiety isn't happening in isolation. It's happening in a universe where even nothing is something, where emptiness vibrates with potential. The thoughts that terrorize you, they arise from quantum processes in your neurons, firing patterns influenced by particles that obey probability rather than certainty. You are not a deterministic machine. You are a probability cloud that somehow learned to worry. And here's the beautiful part. If the universe at its smallest scale operates on uncertainty, then your future isn't written. The anxiety that tells you everything is predetermined, that you're trapped on rails heading toward disaster, it's lying to you. quantum mechanics proves it wrong. Let me be clear. I'm not suggesting you can manifest reality by thinking happy thoughts. That's not physics. That's wishful thinking dressed in scientific language. But I am telling you that the fundamental nature of reality includes genuine openness. Possibility isn't an illusion. It's built into the fabric of existence. Fact number 10. Your body replaces most of its atoms every few years. The calcium in your bones, the carbon in your DNA, the iron in your blood, none of it is permanent. You are a pattern, not a substance, a process, not a thing. The you that's reading this is materially different from the you that existed 7 years ago, yet you remain continuous in experience. This should terrify us, but instead, I find it liberating. Because if I'm not the same atoms, if I'm not the same cells, if I'm not even the same thoughts I had when I woke up this morning, then what am I actually losing when I die? Perhaps death is simply the moment when the pattern stops updating, when the process ceases to continue. But patterns have a curious property. They can be recreated, they can be transmitted, they can exist in multiple substrates simultaneously. You see, this is where my colleagues in physics would become uncomfortable. They prefer their conservation laws neat and tidy. Energy cannot be created or destroyed, only transformed. But information? Information is stranger. Information can be copied. It can spread. And if consciousness is information arranged in a particular pattern, I'm not suggesting immortality in the traditional sense. That's the fantasy of frightened egos. No, what I'm suggesting is far more unsettling, that the boundary between one consciousness and another may be far more permeable than we assume. When you understand an idea, truly understand it, you're not just storing words in your memory. You're recreating in your neural tissue the same pattern of relationships that existed in mine when I first conceived it. For that moment, we are thinking the same thought. The pattern is alive in both of us simultaneously. This is why I spent my life trying to understand the universe rather than conquer it. Conquest requires an ego to claim credit. Understanding requires only accurate transmission of patterns. When I worked out the field equations, I wasn't creating something new. I was discovering a pattern that existed before I was born and will exist after I'm gone. I was simply the temporary substrate through which the universe came to understand itself. You might say, but Einstein, surely your unique genius mattered. Surely someone else wouldn't have seen what you saw. Perhaps, perhaps not. But here's what troubles me. The idea that my consciousness is special, unique, irreplaceable. This is exactly the illusion that causes suffering. It's the source of every fear, every grasping desire, every defensive reaction, the ego's desperate insistence that I must persist. But watch a child learn to walk. The falls, the attempts, the gradual mastery. At what point does the child become someone who can walk? There's no single moment. It's a gradual pattern shift, a reorganization of neural pathways and muscle memory. The old pattern doesn't die, it transforms. It becomes something new. That's what I think death might be. Not an ending, but a transformation so complete that the pattern can no longer maintain the illusion of continuity we call self. And if that pattern disperses, if those relationships dissolve back into the universe they came from, then perhaps I haven't truly died. Perhaps I've simply returned to a state I never really left, the vast, interconnected field of existence itself. You see, we think of ourselves as isolated islands, separate, distinct, but physics tells a different story. Every atom in your body was forged in the heart of a dying star billions of years ago. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in the nuclear furnace of ancient supernovae. You are literally made of stardust. This isn't poetry, it's atomic fact. And these atoms don't belong to you. They're on loan. Every few years, most of the atoms in your body are replaced through the food you eat, the water you drink, the air you breathe. The matter that forms you today will be part of trees, oceans, other people tomorrow. You're not a closed system. You're a temporary confluence, a brief gathering of elements that will scatter again. So when I ask, what dies when you die? The answer becomes less clear. The matter continues. The energy continues it must, by the first law of thermodynamics. Energy cannot be created or destroyed, only transformed. The particular arrangement changes, yes, but the fundamental constituents? They simply move on to their next configuration. This understanding doesn't diminish the significance of death. If anything, it deepens it, because what it means is that you, the you reading this now, are an impossibly rare arrangement. The odds that these specific atoms would come together in precisely this way, at this moment in cosmic history, with this particular consciousness observing the universe, astronomically small, you are a statistical miracle, a universe that has organized itself into a form capable of looking back at itself with wonder. And perhaps that is the deepest tragedy of modern existence. We have forgotten how to wonder. We walk through our days as if consciousness were common, as if the universe producing minds capable of mathematics, music, and meaning were somehow ordinary. But it is not ordinary. It is the most extraordinary thing that has ever happened. Consider this. Every thought you have, every memory you cherish, every decision you make, all of it emerges from approximately 86 billion neurons firing in patterns so complex that we have barely begun to understand them. Your brain consumes 20% of your body's energy to maintain this magnificent symphony of electricity and chemistry. And what does it create? Not just survival responses, not just instinct. It creates poetry, philosophy. It creates the ability to contemplate infinity while standing in a finite body. It creates the capacity to love something so deeply that you would sacrifice your own existence for it. This is not a side effect. This is not evolutionary noise. This is matter becoming aware of itself in the most profound way possible. I spent my life searching for the fundamental laws that govern reality. I wanted to read the mind of God, as I used to say. And what I discovered, again and again, was that the universe appears to be structured in a way that makes understanding possible. The mathematics we use to describe reality, it works unreasonably well. The equations we write on blackboards predict the motion of galaxies we have never seen. They describe the behavior of particles too small to imagine. Why? Why should human mathematics, born from counting sheep and measuring grain, be capable of unlocking the deepest secrets of the cosmos? Unless consciousness and cosmos are not separate things, unless mind and matter are two expressions of the same underlying reality, you are not in the universe. You are not a tourist passing through. You are the universe, a portion of it that has become sufficiently complex to think, to feel, to question its own existence. When you look up at the stars, you are literally the universe looking at itself. When you feel wonder at the beauty of a sunset, you are the cosmos experiencing its own magnificence. This is not philosophy or poetry, this is physics. The atoms in your body were forged in the hearts of dying stars billions of years ago. The iron in your blood, the calcium in your bones, the carbon in your DNA, these elements were created in stellar furnaces through nuclear fusion. When those massive stars exhausted their fuel and exploded as supernovae, they scattered these precious elements across space. Eventually, they coalesced into new solar systems, new planets, and ultimately, into you. You are made of stardust. This is not metaphor, it is literal scientific fact. Every breath you take contains atoms that once resided in stars, that once drifted through interstellar clouds, that were once part of dinosaurs, of ancient trees, of other human beings who lived centuries ago. The boundary between you and the universe is arbitrary, permeable, ultimately illusory. And here is where it becomes truly extraordinary. You are not just any arrangement of cosmic matter. You are matter that has organized itself in such a way that it can contemplate its own existence. Think about that for a moment. The universe spent 13.8 billion years evolving from a hot, dense state into galaxies, stars, planets, and eventually into conscious beings capable of understanding that very evolution. You represent the universe's capacity for self-reflection. When I developed the theory of relativity, I wasn't discovering something external to myself. I was the universe using one of its temporary forms, my mind, to understand its own fundamental structure. When you solve a problem, create art, feel love, or simply notice the warmth of sunlight on your skin, you are the cosmos experiencing itself through your particular configuration of matter and energy. This understanding transforms everything. Your suffering is the universe's suffering. Your joy is its joy. Your curiosity about existence is existence being curious about itself. You are not observing reality from the outside. You are reality, experiencing itself from one infinitely precious perspective among countless others. When I developed the theory of general relativity, I realized that space and time are not separate containers holding the universe. They are the universe, bending and flowing with mass and energy. In the same way, consciousness is not something separate from the cosmos. It is the cosmos, experiencing itself through billions of eyes, minds, and hearts. You think you're looking at stars, but the truth is far more beautiful. You are stars, looking back at yourself. Every atom in your body was forged in the nuclear furnace of dying stars billions of years ago. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created when massive suns exploded and scattered their enriched matter across space. You are literally made of stardust. This isn't poetry. This is physics. But here's what makes my heart sing with wonder. Those atoms didn't just randomly organize into your body. They organized in such a way that they became aware of their own cosmic origin. The universe spent 13.8 billion years arranging matter with such precision that it could wake up and contemplate its own existence. You are that awakening. When you look up at the night sky and feel that sense of awe, what's actually happening? Matter that was once scattered across galaxies, compressed in stellar cores, blown apart in supernovae, reformed in planetary systems, evolved through billions of years of life, that matter has now organized itself into a pattern called you, and it's looking back at the cosmos from which it came. The universe is not just observed by you, it is experiencing itself through you. This means something profound. Your life is not a random accident that needs external justification. Your existence is the universe's way of knowing itself. Every question you ask about reality is reality questioning itself. Every moment of beauty you witness is beauty witnessing itself. Every time you love another person, the cosmos is loving itself through you. This is not merely poetry, this is the deepest truth physics can reveal. When I looked at another human being, I was not looking times at times them. I was looking times through times them, into the same infinite mystery that looked through me. The boundaries we draw between self and other, between observer and observed, between knower and known, these are grammatical conveniences, not metaphysical truths. You think you are separate because you experience yourself as a localized point of view, but consider, where does your consciousness actually end? You might say it ends at your skin, but your skin is constantly exchanging atoms with the air around you. In 7 years, nearly every atom in your body will have been replaced. Are you still you? The answer is both no and yes. No, you are not the same collection of particles. Yes, you are the same pattern, the same process, the same temporary whirlpool in the river. You are not a noun, you are a verb. You are not a thing that exists. You are existence happening in a particular way. And here is where it becomes profound beyond measure. Every other conscious being is the same process. We are all localized expressions of the same underlying reality, asking itself what it is. We are the universe's way of exploring the infinite possibilities of what it means to times be asterisk. When you help another person, you are not performing an act of charity towards someone separate from yourself. You are the universe caring for itself. When you harm another, you are the cosmos inflicting a wound upon itself. Ethics, therefore, is not imposed from outside by some cosmic lawgiver. Ethics emerges naturally from recognizing what you actually are. I spent years pondering the deepest questions of existence. In my final decades, I realized something that no equation could capture. The distinction between science and spirituality is false. They are both attempts to understand what this is, this extraordinary fact of existence. Science approaches it through measurement and mathematics. Spirituality approaches it through direct experience and contemplation, but they are pointing at the same moon. And perhaps this is where our modern world has lost its way. We have become so specialized, so fragmented in our thinking, that we've forgotten how to see the whole. The scientist dismisses the mystic as a dreamer. The religious person fears the scientist as a destroyer of meaning. But this division, it is artificial. It is a wound we have inflicted upon ourselves. I have spent my life in equations, in laboratories, in the abstract realm of theoretical physics. Yet I have never felt that this work separated me from the sacred. Quite the opposite. The deeper I went into the mathematics of the universe, the more I felt I was touching something holy. Not holy in the sense of Sunday sermons or prescribed rituals, but holy in the sense of profound reverence, of overwhelming awe at the intricate beauty that underlies all existence. When I see a flower blooming in my garden, I can appreciate it on multiple levels simultaneously. I can enjoy its colour and fragrance as any person would. I can understand the biological processes that created it, the photosynthesis, the cellular division, the evolutionary pressures that shaped its form. And I can marvel at the quantum dance happening in every atom of its petals, the electromagnetic forces holding it together, the way it converts starlight into structure and scent. None of these ways of seeing diminishes the others. They enrich each other. The flower becomes more miraculous, not less, when I understand the science behind it. And the science becomes more meaningful when I approach it with wonder rather than mere technical curiosity. This is what I mean when I speak of cosmic religious feeling. It is the recognition that knowledge and mystery are not opposites, they are partners in an eternal dance. Every answer we discover reveals new questions. Every mystery we penetrate opens doors to deeper mysteries. The universe is not a puzzle to be solved and then discarded. It is an infinite source of wonder that rewards both our intellect and our capacity for awe. So I say to you, do not let anyone tell you that you must choose between reason and reverence, between science and soul. These are false choices, created by small minds who cannot hold complexity. The truly expansive mind, the mind that wishes to touch reality in its fullness, must learn to embrace both. The question then becomes, how do we cultivate this expansive mind? How do we develop the capacity to hold these seeming contradictions without collapsing into confusion or cynicism? I will tell you what worked for me, though I claim no universal method. I practiced what I call disciplined wonder. On one hand, I subjected every idea to rigorous scrutiny. I demanded mathematical proof, experimental verification, logical consistency. I was merciless with lazy thinking, including my own. But on the other hand, I protected carefully a space within myself where imagination could roam free, where I could ask absurd questions without immediate judgment, where I could play with ideas the way a child plays with blocks. This is harder than it sounds. The temptation is always to collapse into one mode or the other. Pure rationality becomes sterile, grinding away at smaller and smaller questions until you forget why you asked them in the first place. Pure imagination becomes unmoored fantasy, producing beautiful dreams that explain nothing and predict less. The balance requires what I think of as cognitive courage. It takes courage to follow logic wherever it leads, even when it contradicts everything you were taught to believe. It took courage for me to abandon the absolute nature of time, which seemed as obvious as breathing. But it also takes courage to trust your intuitions, to pursue questions that seem foolish, to spend years on problems that might lead nowhere. I spent much time thinking about light, how it could be both wave and particle, how its speed could remain constant regardless of the observer's motion. These ideas seemed crazy, even to me. Many nights I doubted myself. The mathematics was elegant, yes, but perhaps I was simply clever at manipulating symbols while losing touch with reality. But there was one test I couldn't ignore. If light truly bent around massive objects, then the stars near the sun should appear shifted from their normal positions during a solar eclipse. This wasn't philosophy anymore. This was a prediction that could be tested, verified, or destroyed by actual observation. I published this prediction in 1911, then refined it further in my 1915 papers. The war made testing impossible for years. Most scientists had bigger concerns than measuring starlight during eclipses. But I waited. I had no choice but to wait. Then came Arthur Eddington, a British astronomer who saw beyond the hatred between nations, who believed that truth transcended borders. He organized expeditions to photograph the solar eclipse of May 29th, 1919, from two locations, Sobral in Brazil and Principe, an island off the coast of Africa. When I received the telegram with the results, my hands trembled, not from nervousness. Exactly. By then, I was certain the theory was correct. How could something so beautiful not be true? But still, there's a difference between mathematical certainty and seeing nature confirm your deepest intuitions. The measurements matched my predictions. Light from distant stars had indeed bent around the sun by the exact amount I had calculated. Space itself was curved, just as I had imagined while lying in that meadow years ago. Overnight, everything changed. Newspapers around the world proclaimed that Newton had been overthrown, that space and time were not what we thought, that some patent clerk from Switzerland had rewritten the rules of the universe. The headlines were absurd, but I understood why they captured people's imagination. We all want to believe that reality is stranger and more wonderful than it appears. The fame that followed was both thrilling and suffocating. Strangers stopped me on the street. Photographers demanded I pose. Journalists asked me to explain the universe in 3 sentences. I became a celebrity, which seemed ridiculous for someone whose work consisted entirely of thinking about problems that had no practical application whatsoever. But here's what nobody tells you about vindication. It doesn't feel the way you imagine. Yes, there's satisfaction, but there's also a strange emptiness. When you've been fighting for so long, the fight itself becomes part of your identity. And when it's finally over, when they finally admit you were right, there's this peculiar moment of, now what? I remember 1919 vividly. Arthur Eddington's eclipse expedition had confirmed my predictions about light bending around the sun. The newspapers exploded. Newton overthrown, they declared. Overnight, I went from obscure patent clerk turned professor to international celebrity, and yes, I felt vindicated. Of course I did, but I also felt unmoored. The controversy had given me purpose, drive, something to prove. It had sharpened my thinking, forced me to defend every assumption, to make my arguments airtight. The resistance had made me better. Now suddenly everyone wanted to agree with me, and that brought its own problems. People started treating my casual observations as profound truths. I'd make a joke, and they'd quote it as philosophy. I'd speculate about something outside my expertise, and they'd take it as gospel. The very people who had dismissed me now hung on my every word, often understanding even less than my earlier critics. This is the paradox of vindication. You spend years wishing people would listen, then they do, and you realize many of them still aren't really hearing you. They're just following the crowd in a different direction. And here's the uncomfortable truth. Your critics often understood your work better than your admirers. They at least engaged with the substance. Many of my supporters simply accepted relativity because important people said it was true, not because they grasped what it meant. The German physicist Philipp Lenard, who became one of my harshest critics, at least understood the physics well enough to attack it intelligently. Some of my admirers couldn't explain the basics if their lives depended on it. So vindication becomes this double-edged sword. You're right. Everyone finally admits it. But the quality of discourse doesn't necessarily improve. Sometimes it gets worse. And there's something else, something darker. When you're vindicated, you face a new temptation to believe you're always right. I've caught myself in this trap more times than I care to admit. After the 1919 eclipse confirmed my predictions, doors opened everywhere. Suddenly, I was the genius who revolutionized physics. And with that label came a dangerous assumption that my brilliance extended to everything. I started speaking about politics, about society, about matters far removed from curved space-time and light quanta. Sometimes I was right. Often, I was just another person with an opinion, dressed up in the costume of scientific authority. The vindication in one domain created a blind spot. I began to trust my intuition too readily, to mistake confidence for correctness. This is the shadow side of being right when others are wrong. It can inflate your sense of infallibility. You start to see disagreement itself as evidence of others' blindness rather than possibly your own incomplete understanding. The very same isolation that once sharpened your thinking can now insulate you from necessary criticism. I think of my decades-long resistance to quantum mechanics. God does not play dice with the universe, I declared, again and again. But was I defending a profound truth or clinging to aesthetic preferences? Was I Galileo standing firm, or the cardinals refusing to look through the telescope? The distinction isn't always clear from the inside. Here's what I learned. Vindication should humble you, not embolden you. When you're proven right, remember how many times the lonely contrarian was simply wrong. Remember that your correctness in one instance doesn't guarantee wisdom in the next. The cosmos doesn't care about your track record. It will contradict you the moment you stop listening. The truly wise person holds their convictions firmly but not rigidly. They maintain what I call flexible certainty, the ability to be confident enough to stand alone, yet humble enough to change course when evidence demands it. I learned this lesson painfully in my debates about quantum mechanics. For years, I argued against the probabilistic interpretation, convinced that God does not play dice with the universe. I had intuition. I had philosophical arguments. I even had Einstein on my side, because I was Einstein. And yet, the experimental evidence kept mounting against my position. The universe, it seemed, was not interested in my aesthetic preferences. Now, I could have dug in deeper. I could have constructed ever more elaborate explanations to preserve my worldview. Many brilliant minds have destroyed their later careers doing exactly this, becoming fossils of their former insights, armed guards protecting yesterday's revolution from today's evidence. But there's no dignity in that kind of stubbornness. The courage isn't in never being wrong. It's in recognizing when you are and adjusting accordingly. This is where most people misunderstand intellectual honesty. They think it means never taking a strong position, always hedging, perpetually sitting on the fence. That's not wisdom, that's paralysis dressed up as sophistication. Real intellectual courage means making bold claims based on your best understanding, then having the strength to revise them when warranted. It's the difference between a closed fist and an open hand. Both can be strong, but only one can receive something new. I think of science as a conversation across time. Each generation inherits the best answers of the previous one, tests them, refines them, and occasionally overturns them completely. This isn't a failure of the system, it's the system working exactly as designed. Newton gave us a universe of clockwork precision. I showed where that clockwork breaks down. Someone after me will show where my equations fail. This isn't tragedy, it's progress. When I left Germany in 1933, I knew I wouldn't return. Not to that Germany. The students burning books in Berlin, among them, books about relativity, weren't just destroying paper. They were burning the idea that truth transcends borders, that an equation doesn't care about your race or nationality. I received a letter once titled 100 Authors Against Einstein, 100 Scientists, all declaring my work wrong. I laughed when I read it. I told a friend, if I were wrong, one would have been enough. It wasn't arrogance. It was something deeper. Truth doesn't require consensus. The universe doesn't vote on its laws. Either the math works or it doesn't. Either the predictions match reality or they don't. But here's what haunted me. Those 100 scientists weren't all fools. Many were competent. Some I'd even respected. What made them sign their names to political propaganda dressed as science? Fear, ambition, the human need to belong. The same forces that make us social creatures, that let us build civilizations, can also make us abandon reason when the tribe demands it. I thought about this constantly in Princeton. Safe in America, while colleagues perished in Europe. The guilt of survival is its own physics, a weight that doesn't decrease with distance. People ask why I spent my last decades chasing a unified field theory that never materialized. Why I became, in their eyes, a stubborn old man refusing to accept quantum mechanics, even though I'd helped birth it. They misunderstand. I accepted quantum mechanics as correct. The math worked too beautifully to deny. What I couldn't accept was that it was complete. God doesn't play dice with the universe, they quote me saying. But I wasn't talking about gambling or randomness. I was talking about something deeper, whether reality exists independent of observation, or whether the universe is fundamentally observer-dependent. Quantum mechanics says you can't know both position and momentum precisely, not because our instruments are crude, but because particles don't have definite positions until measured. The moon, I joked, doesn't exist when nobody's looking at it. This bothered me not because it was strange, but because it suggested we'd stopped asking why. We'd found equations that predicted everything perfectly, and we shrugged and said, that's just how it is. But every time physics said that's just how it is, someone eventually found a deeper layer. When I looked at quantum mechanics, I saw a theory that worked brilliantly, but explained nothing about reality itself. It was like having a map that predicted every turn in the road without telling you why the road was built there in the first place. My instinct told me there had to be hidden variables, some deeper clockwork we hadn't discovered yet. I was wrong about that specific mechanism, but I wasn't wrong to keep asking. The real breakthrough in understanding came from a man named John Bell in the 1960 seconds. He proved mathematically that if hidden variables existed the way I imagined them, they would have to communicate faster than light to produce quantum mechanics predictions. When experiments tested this, they found that quantum mechanics was right, and my hidden variables were wrong. But here's what everyone misses. Bell's theorem didn't end the conversation. It deepened it. It told us that reality itself is fundamentally non-local. Two particles can be connected in ways that transcend space itself. Think about what this means. You measure a particle here, and instantaneously, not just quickly but truly instantaneously, a particle a billion light-years away responds. Not because information traveled between them, but because in some profound sense, they were never really separate. The universe doesn't consist of isolated objects bumping into each other like billiard balls. It's a unified whole that we've artificially carved into pieces with our concepts and categories. This bothered people even more than uncertainty did. At least uncertainty felt like ignorance, a limitation we might overcome. But non-locality felt like magic, like physics had given up on being physics. And yet there it was, confirmed in laboratory after laboratory. The universe was telling us something fundamental. The separateness we experience, the sense that you are here and I am there, is a useful illusion, not ultimate truth. I spent my later years trying to find a unified field theory that would explain both gravity and quantum mechanics, both the cosmic and the atomic. I never succeeded. But I don't think I failed either. Every wrong turn taught us something about where the answer couldn't hide. Every failed approach narrowed the search space for whoever would come after me. And that's the part nobody tells you about science. We celebrate the breakthroughs, the eureka moments, the elegant theories that change everything, but we don't talk enough about the years spent wandering in the dark, feeling along walls that seem to have no doors. I spent decades on unified field theory. Decades. While quantum mechanics was revolutionizing physics, while brilliant minds were making discovery after discovery, I was still there, still searching for that deeper unity I knew had to exist. Some colleagues thought I'd become stubborn, obsessed, unable to let go of my own vision. Maybe they were right, or maybe I just understood that the biggest questions require more than a lifetime to answer. You see, there's something almost beautiful about working on a problem you know you won't solve. It forces you to think about legacy differently. Not what will I achieve, but what will I make possible? Not will I find the answer, but can I ask the question clearly enough that someone else will understand what I was reaching for? I think about that violin maker in Cremona again, Antonio Stradivari. He spent his entire life trying to create the perfect instrument. And maybe, in some absolute sense, he never did. But he got close enough that 300 years later, people are still playing his violins, still trying to understand his secrets. He didn't solve music, he just made it more beautiful. That's what I hope for my work on unification. Not that I found the answer, but that I made the question irresistible. That somewhere, someone will pick up where I left off, will see something I missed, will have access to mathematics or experimental data that didn't exist in my time. Because that's how science actually works. It's not lonely geniuses having perfect insights. It's a relay race across generations, each runner carrying the baton a little further before passing it on. Newton gave me the baton. I ran my leg of the race, and now I've passed it forward to you, to whoever comes next. The universe doesn't care about my ego or my legacy. It just keeps being itself, magnificently indifferent to whether we understand it or not. But we keep trying anyway, because that's what it means to be human, to see something vast and mysterious, and to say, I want to know, I need to understand. And perhaps that's the greatest gift quantum mechanics has given us, not answers, but better questions. Not certainty, but a framework for embracing uncertainty with rigor and precision. When I look back at my own journey, I see how much I resisted this lesson. I spent decades trying to prove that quantum mechanics was incomplete, that there had to be hidden variables beneath the surface, some deeper layer of reality where everything made sense again. I was wrong, not about the questions, but about what I was looking for. The universe doesn't owe us comfort. It doesn't owe us intuition. What it offers instead is something far more precious: truth, even when that truth is strange, even when it forces us to rebuild our entire understanding of what reality means. You know what haunts me most? It's not that I was wrong about quantum mechanics. It's that I almost let my discomfort prevent others from exploring its full implications. I could have been the one to develop quantum field theory. I could have been the one to discover quantum entanglement's full potential, but I was too busy being uncomfortable, too invested in the world making sense in the way I wanted it to. Don't make my mistake. When you encounter something that makes you uncomfortable, something that violates your intuition about how things should work, lean into that discomfort. That's where the discoveries are hiding. The young physicists today, they're doing remarkable things. They're building quantum computers that exploit superposition and entanglement. They're testing Bell's inequalities with ever greater precision. They're exploring quantum biology, discovering that nature herself has been using quantum effects for billions of years in photosynthesis, in bird navigation, in the very chemistry of life. They're not asking whether quantum mechanics is strange. They're asking what we can do with that strangeness. That's progress. That's how science moves forward, not by making the universe conform to our preferences, but by conforming our understanding to what the universe actually shows us. And I find tremendous beauty in this journey of understanding. When I was a young man working in the patent office, spending my days evaluating other people's inventions, I would look out the window and imagine riding alongside a beam of light. What would I see? What would I experience? These weren't frivolous daydreams, they were thought experiments that eventually led to relativity. The key was allowing myself to truly imagine the impossible, to follow the logic wherever it led, even when it meant accepting that time itself could stretch and compress, that simultaneity was an illusion, that mass and energy were the same thing wearing different clothes. You see, the universe doesn't care about our intuitions. Our brains evolved to help us avoid predators and find food on the African savanna, not to comprehend the quantum realm or the structure of space-time. So of course, quantum mechanics feels strange. We're using Stone Age hardware to run cutting-edge software, but here's what gives me hope. Throughout history, what seemed impossible eventually became mundane. The idea that Earth orbits the Sun was once heretical. The notion that matter is made of atoms was controversial. The suggestion that light has a speed limit seemed absurd. Now these ideas are taught to children. Quantum computing will follow the same path. What seems like pure magic today, particles existing in multiple states, information teleporting across space, computations happening in parallel universes, will one day be as commonplace as sending an email or making a phone call. I can already see the seeds of this transformation. Young students today grow up learning about quantum mechanics from the beginning. They don't carry the same classical baggage that my generation did. To them, superposition isn't weird, it's just how the universe works. They're building the intuitions that will make quantum computing not just possible, but natural. This generational shift in understanding is perhaps more important than any technological breakthrough. We need people who can think quantum, who can dream in probabilities rather than certainties, who can see possibility spaces rather than fixed outcomes. Because ultimately, quantum computing isn't just about building faster machines. It's about expanding what humanity can imagine and achieve. Think about what we're really doing when we build a quantum computer. We're not just assembling hardware. We're creating a bridge between the abstract mathematics that describes reality at its most fundamental level and the practical world where we solve actual problems. We're taking the bizarre, counterintuitive rules that govern atoms and photons and saying, these aren't just curiosities to observe in laboratories. These are resources we can harness. This is perhaps the most profound shift in our relationship with quantum mechanics since its inception. For nearly a century, quantum physics was something we studied, something we marveled at, something that challenged our philosophical assumptions about reality. But it remained largely theoretical, confined to explaining phenomena we observed rather than creating new capabilities we could control. Quantum computing changes that equation completely. It transforms quantum mechanics from a descriptive theory into a prescriptive technology. We're no longer just passive observers of quantum weirdness. We're active participants, quantum engineers who design systems that exploit these effects deliberately and systematically. And here's what keeps me up at night with excitement. We're still in the earliest stages of understanding what this really means. The quantum algorithms we have today, revolutionary as they are, probably represent only a tiny fraction of what's possible. We're like the Wright brothers with their first aircraft, having no conception that someday their invention would carry millions of people across oceans every day, connect continents, reshape global commerce. What quantum algorithms haven't we discovered yet? What applications haven't we imagined? What problems that seem utterly intractable today will become routine calculations tomorrow? The state space of possibilities is so vast that our current exploration barely scratches the surface. Consider this parallel. When classical computing emerged, nobody predicted social networks, streaming video, artificial intelligence, or smartphones. The inventors of the first computers imagined they might need perhaps a dozen such machines in the entire world. They couldn't foresee how computation would weave itself into every aspect of modern life, because the applications emerged only after the technology matured and people had time to experiment, to play, to discover unexpected uses. We're at that same inflection point with quantum computing, except the potential trajectory is even more dramatic, because quantum computers don't just do what classical computers do faster. They operate on fundamentally different principles, which means they'll enable fundamentally different applications. Think about it this way. A classical computer processes information in bits, each one definitively a 0 or a 1, like a light switch that's either on or off. Every calculation, no matter how complex, is built from these simple binary choices strung together in sequence. It's remarkably powerful, obviously, given what we've accomplished with classical computing. But there are certain problems where this approach hits a wall, problems where the number of possible solutions grows so explosively that even checking all the possibilities would take longer than the age of the universe. Quantum computers work differently. They use quantum bits, or qubits, which can exist in superposition, simultaneously representing both 0 and 1 until measured. It's not that they're both at once in the classical sense. Rather, they exist in a probabilistic state that contains information about both possibilities. When you have multiple qubits working together, they can explore vast solution spaces in parallel, testing countless pathways simultaneously through quantum interference, amplifying the probability of correct answers while suppressing wrong ones. This isn't just a faster version of what we already have. It's a fundamentally different computational paradigm. And just as transistors enabled applications nobody predicted, quantum computation will unlock possibilities we can't fully imagine yet. We know some things it should revolutionize. Drug discovery, for instance, where quantum computers could simulate molecular interactions with precision impossible for classical machines, potentially designing medicines in months instead of decades. Materials science, where they might discover room temperature superconductors or ultra-efficient solar cells by modeling quantum mechanical behavior directly. Cryptography, financial modeling, artificial intelligence, optimization problems that plague everything from traffic flow to supply chains. But here's what keeps me up at night in the best possible way. I think the most transformative applications haven't been conceived yet. Someone will eventually do with quantum computers what nobody imagined doing with transistors in 1947. They'll find a use case so novel, so unexpected, that it creates entirely new fields of inquiry. And you know what? That's the part that fills me with the most profound sense of wonder. Because throughout history, the most revolutionary breakthroughs weren't planned in some grand strategic document. They emerged when curious minds had access to powerful tools and the freedom to ask absurd questions. Think about lasers for a moment. When we first developed the theoretical framework for stimulated emission, nobody was thinking about eye surgery or fiber optic cables or barcode scanners. Einstein himself, well, that's me. I just thought it was an interesting quirk of quantum mechanics. Now, they're everywhere, doing things I never imagined. Or consider the internet. The protocols that now connect billions of humans were designed by researchers who just wanted to share data between a handful of universities. They weren't trying to revolutionize commerce, entertainment, education, and human relationships. They were solving a narrow technical problem, and the universe surprised them with emergent possibilities. Quantum computers will follow this same pattern, but amplified, because they're not just faster calculators, they're fundamentally different engines of possibility. They let us explore regions of reality that classical computers can't even point toward. Here's a thought experiment I've been playing with. What if we could use quantum computers to simulate consciousness itself? Not artificial intelligence in the traditional sense, but actual modeling of quantum processes in microtubules, testing whether consciousness has quantum mechanical origins. It's speculative, yes, wildly so. But suddenly we have tools that might actually test Penrose's theories experimentally rather than just philosophically. Or imagine quantum computers tackling the protein folding problem, not just for medical applications, but to understand how life bootstrapped itself from chemistry. Could we simulate the conditions of early Earth and watch, in quantum detail, as self-replicating molecules first emerged? Could we answer the deepest question of biology? What is the minimal set of conditions for life to spontaneously arise? These aren't predictions, they're invitations. I'm sketching possibility space, showing you how wide the door has opened. The actual applications will come from people who see connections I'm blind to, who bring expertise from fields I've never studied, who ask questions shaped by experiences I've never had. That's the beauty of transformative technology. It doesn't just solve existing problems, it makes new questions askable. It turns philosophy into physics, speculation into experimentation, dreams into hypotheses that can actually be tested. And here's what thrills me most. The children born today won't remember a time when these tools didn't exist. They'll grow up in a world where conversing with an AI is as natural as using a calculator, where generating images from text is as mundane as taking a photograph, where having access to the sum of human knowledge is simply the baseline expectation. You know what that means? They'll ask entirely different questions than we did. When I was young, becoming educated meant memorizing vast amounts of information. You had to carry libraries in your mind because access was the bottleneck. Now, access is solved. The bottleneck has shifted entirely to discernment, to wisdom, to knowing which questions matter and how to evaluate the answers you receive. These kids won't waste cognitive energy on what can be looked up. They'll focus on what can be imagined, on what can be synthesized, on connections between ideas that no search engine would ever suggest, because the connection itself is novel. Think about that shift. For thousands of years, education meant filling vessels. Now it means lighting fires. It means teaching not what to think, but how to think, how to question, how to create frameworks rather than memorize facts. And yes, this terrifies some people. I understand that. Change always does. There are educators worried that students will use these tools to cheat, to avoid learning. And sure, some will. Some always have. But the solution isn't to ban the tools, it's to change what we mean by learning. When I was developing relativity, I didn't avoid using mathematics because it made the problems easier. I used every tool available because the goal wasn't to struggle, it was to understand. The difficulty should be in the thinking, not in the mechanics of computation. That's the educational revolution these tools enable. Instead of testing whether students can perform tasks that machines now do better, we can finally focus on developing the uniquely human capacities: creativity, ethical reasoning, emotional intelligence, the ability to recognize what questions are worth asking in the first place. Imagine classrooms where students don't memorize dates but instead use AI to explore counterfactual histories. What if this battle had gone differently? What ripple effects would have cascaded through time? They're not just learning history, they're learning systems, thinking, cause and effect, the contingency of everything we take for granted. Or science classes where instead of running the same predetermined experiments that millions have done before, students design their own investigations, using AI to model complex systems, to visualize molecular interactions, to test hypotheses in simulation before building physical prototypes. They're not memorizing the periodic table, they're understanding why elements behave the way they do, predicting properties of new compounds, engaging with chemistry as a living language rather than a dead catalogue of facts. And here's what truly excites me. These aren't separate subjects anymore. The artificial boundaries we've maintained between mathematics and art, between science and philosophy, between history and technology, they dissolve when students pursue genuine questions. A student investigating urban sustainability needs economics, environmental science, social studies, data analysis, and design thinking simultaneously. The real world doesn't come in 50-minute periods labeled by discipline. I've watched teachers transform when given these tools. One educator told me she'd spent 15 years teaching the same literature curriculum, watching students dutifully read assigned books without real engagement. Then she started letting students use AI to explore themes across cultures, to compare how different societies tell similar stories, to trace the evolution of narrative structures through time. Suddenly her classroom became electric with discovery. Students were reading more, not less, following threads of genuine curiosity rather than marching through required texts. But here's what matters most. They were developing taste, judgment, critical thinking. The AI could summarize any book in seconds, but students learned that summaries aren't understanding. They discovered that wrestling with complex texts, comparing interpretations, forming and defending their own readings. This is where real learning happens. The technology amplified their capacity for analysis rather than replacing it. This is the paradigm shift we're witnessing. Education is moving from information transmission to wisdom cultivation, from preparing students for a known world to preparing them for an unknowable one. The question isn't, what do students need to know, but what do students need to be able to do with what they discover? And the answer, I believe, is this. They need to think critically, question deeply, create boldly, collaborate effectively, and adapt continuously. They need to understand systems, see patterns, make connections across domains. They need to be comfortable with uncertainty, skilled at learning itself, capable of teaching themselves whatever the future demands. These capabilities don't emerge from memorization. They emerge from wrestling with real questions, making actual things, solving genuine problems. They emerge when a student isn't simply told that climate systems are complex, but instead spends weeks modeling one, watching how changing a single variable cascades through the entire system, feeling in their bones how interconnected everything truly is. I've watched this transformation happen. A young woman who struggled with traditional math suddenly excels when she's using statistical analysis to investigate whether her community's water is safe. A boy who seemed disengaged comes alive when he's programming a robot to navigate obstacles, debugging his code at midnight, not because it's homework, but because he needs to see if his solution works. A quiet student finds her voice when she's presenting research on local history to city council members who actually implement her recommendations. This is what happens when learning becomes real, when the question isn't, will this be on the test, but will this help me understand my world? Will this let me build something meaningful? Will this give me power to make things better? And here's what troubles me most about our current approach. We've created a system that trains students to wait for permission, to look for the right answer, to stay inside the lines. We reward compliance and penalize creative risk-taking. We've turned education into a process of reproducing existing knowledge rather than generating new understanding. But the future doesn't need excellent memorizers. It needs excellent learners. It doesn't need people who know all the answers. It needs people who know how to find answers, how to ask better questions, how to recognize when old answers no longer apply. Consider how quickly the world is changing. The smartphone in your pocket has more computing power than all of NASA had when they put humans on the moon. Technologies that didn't exist when today's students were born now shape every aspect of daily life. Problems we couldn't have imagined a decade ago demand solutions we haven't yet conceived. In this context, what does it mean to prepare someone for the future? It cannot mean filling them with facts that may be obsolete before they graduate. It must mean something deeper, something more fundamental. It means teaching them to think about thinking itself, to question not just answers, but the questions that produce those answers, to understand that wisdom is not the accumulation of certainty, but the cultivation of productive doubt. I have spent my life in pursuit of understanding, and the greatest lesson I have learned is this. Every answer I found opened 10 new questions. This is not a failure of the scientific method, it is its glory. The purpose of education should not be to close doors, but to reveal how many doors exist that we didn't even know were there. Consider how a child learns to walk. No parent hands them an instruction manual on bipedal locomotion. No one lectures them on the physics of balance and momentum. The child falls, adjusts, falls again, recalibrates. Through iteration and feedback, through embracing failure as information rather than defeat, they master one of the most complex physical tasks they will ever perform, and they do it joyfully. Then we send them to school, and suddenly failure becomes something to be punished, avoided, hidden. We replace curiosity with compliance, exploration with memorization. We take these natural-born scientists and systematically teach them not to experiment. What if we did the opposite? What if we designed education around the principle that not knowing is the beginning of wisdom, not evidence of its absence? What if we celebrated the student who asks the question no one can answer more than the student who memorizes the answers everyone already knows? This would require a fundamental reimagining of what teaching means. The teacher would become less a dispenser of information and more a guide through uncertainty. Their expertise would lie not in having all the answers, but in modeling how to think when answers are elusive, how to formulate better questions, how to distinguish between what we think we know and what we actually know, how to hold multiple contradictory ideas in mind until evidence helps us choose between them. This is uncomfortable. It violates our desire for educational efficiency, for measurable outcomes, for standardized progress. But comfort is not the goal. Transformation is, and transformation only happens at the edge of what we already understand. That edge, that uncomfortable boundary between the known and the unknown, is where I spent most of my life. Not by choice, necessarily, but because the questions wouldn't leave me alone. They followed me like shadows. They whispered in quiet moments. They disrupted my sleep and invaded my daydreams. And here's what I learned about living on that edge. You cannot force insight. You cannot schedule revelation. The mind works in rhythms that defy logic. Sometimes the answer comes in a flash while you're walking by the river. Sometimes it emerges slowly, like dawn breaking over mountains. And sometimes, most times, you must simply hold the question gently in your consciousness and trust that your deeper mind is working even when you're not aware of it. This is the practice that few understand. We celebrate the moment of discovery, the dramatic breakthrough, the triumphant announcement, but we ignore the months and years of patient uncertainty that preceded it. We ignore the quiet discipline of returning to the same problem day after day, even when progress seems invisible. I kept a mental file of unsolved problems, questions I couldn't answer but refused to abandon. And, periodically, without warning, one of them would suddenly become clear, not because I had gained new information, but because my perspective had shifted just enough to reveal what was hidden in plain sight all along. This is why obsession gets such a bad reputation. People see it as unhealthy fixation, but there's a difference between destructive obsession and sacred devotion. The former closes you off from life. The latter opens you to dimensions of reality others never notice. When you truly commit to understanding something deeply, you enter into relationship with it. The problem becomes your companion. You carry it with you. You examine it from different angles. You introduce it to other ideas and watch how they interact. You become intimate with its nuances, its subtleties, its hidden structures. And slowly, almost imperceptibly, the problem changes you. Your mind reorganizes itself around the questions you ask. Your perception sharpens in specific directions. You begin to notice patterns that were always there, but previously invisible to you. This is the real education, the one that happens outside classrooms and textbooks. It's the education of sustained attention, of patient inquiry, of refusing to settle for superficial answers. What fascinates me most about this process is how it mirrors the structure of scientific revolution itself. Before a breakthrough, there's always a period of confusion, of gathering seemingly unrelated observations. Then comes that extraordinary moment when everything clicks into place, when scattered data points suddenly form a coherent picture. I experienced this countless times in my own work. The theory of relativity didn't emerge from a single flash of insight. It came from years of puzzling over thought experiments, of asking uncomfortable questions about concepts everyone else took for granted. Why should time be absolute? Who decided that simultaneity means the same thing for all observers? These weren't sophisticated questions initially. They were the questions of someone refusing to accept answers simply because they were traditional. You have this same power available to you right now. The difference between you and the experts in any field isn't that they possess some magical cognitive ability you lack. It's that they've spent thousands of hours engaged with their subject matter, building mental models through direct experience. But here's what most people miss. You can compress decades of learning into years. years into months, if you learn how to learn efficiently. The key is understanding that knowledge isn't linear, it's networked. Every concept connects to multiple others. When you learn something new, you're not adding a single fact to your mental database. You're creating dozens of potential connections to things you already know. The more connections you forge, the more powerful your understanding becomes. This is why isolated facts, memorized without context, are so forgettable. They're lonely nodes with no connections, easily lost in the vast terrain of your mind. But when you learn something and immediately ask yourself, how does this relate to what I already know? What patterns does this illuminate? What predictions can I make based on this? You're weaving that knowledge into your existing mental fabric. I've watched brilliant minds waste their potential by collecting facts rather than building understanding. They could recite textbooks verbatim but couldn't apply those principles to novel situations. Real intelligence isn't about storage capacity, it's about the richness of connections between ideas. The mind, you see, works nothing like a filing cabinet. It works like a web, a vast, interconnected network where each strand vibrates when another is touched. When I grasped the equivalence of energy and mass, it wasn't because I had memorized more equations than my colleagues. It was because I had spent years playing with concepts, stretching them, rotating them in my imagination, asking what would happen if the rules were slightly different. This is why I always encouraged my students to daydream. Yes, you heard that correctly. Daydream. Let your mind wander into impossible territories. What if you could ride alongside a beam of light? What if time itself could stretch and compress? These aren't frivolous diversions, they're the mental gymnastics that keep your neural pathways flexible and creative. But here's something that troubles me deeply about modern education: the obsession with immediate application. Everything must be practical, useful, marketable. Students ask, when will I ever use this? Before they've even understood what this truly is. They want the destination without the journey, the fruit without tending the tree. I spent years on problems that seemed to have no practical purpose whatsoever. The curvature of space-time? Most people thought I was wasting my time on abstract nonsense. Yet, that useless work eventually revolutionized our understanding of the universe and led to technologies like GPS that people now take for granted. The greatest discoveries rarely come from asking, what can I use this for? They come from asking, isn't this fascinating? I wonder why this happens. Curiosity must be its own reward, or it withers into mere careerism. And let me tell you something about failure that nobody wants to hear. You need more of it. Yes, more failure. Every equation I got wrong, every hypothesis that collapsed under scrutiny, every experiment that produced baffling results, these were my greatest teachers. They forced me to question my assumptions, to look at problems from entirely new angles. Success teaches you very little except to repeat what you've already done. Failure, true, productive failure, reveals the boundaries of your understanding and invites you to expand them. The students I worried about most weren't the ones who struggled. They were the ones who succeeded too easily, who never had to rebuild their understanding from the ground up. I remember a young woman in Berlin who came to one of my lectures in the early 20s. She approached me afterward with a paper she'd written a critique of my field equations that was fundamentally flawed. The mathematics was elegant, but the physical interpretation was backwards. I could have simply corrected her and sent her away. Instead, I asked her a question. What experiment would prove you right and me wrong? She couldn't answer, not because she lacked intelligence, but because she'd fallen in love with her equations without interrogating what they meant about reality. We sat in that lecture hall for 2 hours, and I watched her face transform as she realized that mathematics without physical intuition is just beautiful poetry written in symbols. The failure of her paper became the foundation of her understanding. That's what I mean when I talk about productive failure. It's not about being wrong, it's about using that wrongness as a diagnostic tool. Where did your reasoning break down? What assumption did you make that reality refused to validate? These are not dead ends. They're illuminated pathways, showing you exactly where your understanding needs to deepen. You live in an age that has gamified everything, including failure. You have this peculiar notion that failure is simply a stepping stone to success, something to fail fast at and move beyond. But that's not failure, that's just rapid iteration. Real failure is slower, more uncomfortable. It's sitting with the wreckage of your certainty and asking what you missed. It's the scientific method applied to your own cognition. When I finally understood that gravity wasn't a force but a curvature of space-time, it came after years of productive failures, equations that almost worked, geometries that captured part of the truth but not all of it. Each failure taught me something that no success ever could. The breakthroughs we remember are merely the visible peaks of mountains built from countless invisible failures. Think of Thomas Edison, who didn't fail 10,000 times to create the light bulb he discovered 10,000 ways that didn't work. Each unsuccessful attempt eliminated a pathway, narrowed the possibilities, brought him closer to the solution. That's not persistence despite failure. That's persistence because of what failure teaches. When you stumble in your learning, pay attention to exactly where and how you fell. That precise point of breakdown is where understanding needs to grow. I spent months convinced that absolute time existed throughout the universe, that simultaneous meant the same thing everywhere. Only when I couldn't make the equations balance, when observation refused to align with theory, did I realize that simultaneity itself was relative. The failure forced me to question what seemed unquestionable. Here's what I want you to understand. Your brain is not designed to acquire complex knowledge on the first pass. It's designed to build understanding through iteration, through repeated encounters with ideas from different angles. Each time you return to a concept after initial confusion, you're not starting over, you're ascending a spiral staircase. You see the same ideas from a higher vantage point. The students who grasp relativity most deeply aren't those who understood it immediately. They're the ones who wrestled with it, who felt confused, who asked themselves, but how can that possibly be true? And then worked through the paradoxes. Confusion is the sound of your mental models being challenged, reconstructed, upgraded. I'm telling you this not as empty encouragement, but as scientific truth about how human minds actually learn. Neuroplasticity, the brain's ability to reorganize itself, happens most actively when you struggle at the edge of your current capabilities. Too easy, and no new neural pathways form. Too hard, and you give up before connections can develop. But that sweet spot of productive struggle, that's where learning lives. So the next time you encounter material that makes you feel lost, recognize it for what it is. An opportunity, not an indication of your limitations, but an invitation to expand them. The human brain, you see, has this remarkable quality: it rewires itself based on what you demand of it. Neuroscientists call it neuroplasticity, but I prefer to think of it more simply. Your mind is not a fixed monument. It's a living garden that grows in the direction you tend it. When I was developing the theory of relativity, I didn't succeed because I was inherently smarter than my peers. I succeeded because I was willing to sit with confusion longer than most people could tolerate. There were months, years, even where the mathematics felt like trying to grab smoke with my bare hands. Every equation seemed to slip away the moment I thought I understood it. But here's what I learned. Confusion is not a stop sign. It's a compass. It tells you exactly where the frontier of your understanding currently ends. And frontiers, by their very nature, are meant to be crossed. Most people retreat the moment they feel intellectually uncomfortable. They interpret the sensation of not knowing as evidence that they lack the capacity to know. This is perhaps the greatest tragedy in education. Because that discomfort, that's not weakness. That's your brain recognizing it's about to grow. Think about physical exercise for a moment. When you lift weights, the burn in your muscles isn't a sign you should stop, it's a sign the process is working. You're creating tiny tears in the muscle fiber that your body will repair stronger than before. The discomfort is literally the mechanism of growth. Your brain operates on the same principle. when you encounter material that challenges you, when you have to read the same passage 3 times, when you have to wrestle with concepts that refuse to click immediately, those are the moments where neural pathways are being forged. The struggle isn't a bug in the system. It's the feature that makes learning possible. I've watched brilliant minds waste their potential because they only engaged with material that came easily to them. They accumulated knowledge, yes, but they never developed the intellectual musculature to break new ground. They became libraries instead of laboratories. True mastery requires something different. It requires you to become comfortable with being uncomfortable. It requires you to sit with confusion until clarity emerges naturally. You see, when I was working on the equations that would become general relativity, I spent years in a state of productive confusion. I didn't run from it. I didn't seek immediate answers from others. I sat with the discomfort of not knowing, trusting that my mind was working on the problem, even when I wasn't consciously thinking about it. This is what I call creative incubation. Your subconscious mind is far more powerful than your conscious intellect, but it needs space to work. It needs silence. It needs permission to wander without direction. When you constantly consume information, you deny your mind this essential space. You become like a farmer who plants seeds and then immediately digs them up to check if they're growing. The constant interference prevents the natural process from unfolding. Let me share something that might surprise you. Some of my greatest insights came not at my desk surrounded by books and papers, but during my violin practice. Music allowed my conscious mind to rest, while my subconscious continued processing the problems I'd been wrestling with. Then suddenly, often in the middle of a Mozart sonata, a solution would appear fully formed, as if it had been there all along, just waiting for me to get out of my own way. This is the paradox. The harder you try to force understanding, the more elusive it becomes. But when you relax, when you allow yourself to not know, when you trust the process, that's when breakthroughs happen. That's when genuine learning occurs. So here's what I want you to do. Choose one subject, one deep question that genuinely fascinates you, not something you think you should study, but something that ignites your curiosity. Then commit to it. Give it weeks, months, even years of your attention. Read the original sources. Work through the problems yourself. Make mistakes. Get confused. Stay confused. Let that confusion be your teacher. And whatever you do, resist the temptation to constantly seek validation or answers from others. Trust yourself. Your intellect is more capable than you realize, but it needs time and space to develop. The most independent minds I've encountered all shared this quality. They weren't afraid of silence. They didn't need constant feedback, constant reinforcement, constant noise. They could sit with an idea, sometimes for years, turning it over in their minds, like a jeweler examining a stone from every angle, looking for the facet that would reveal its true nature. I spent 8 years developing the general theory of relativity. 8 years. Not because I was slow, but because the problem demanded that time. During those years, there were long stretches where I seemed to make no progress at all. My colleagues moved on to other problems. Some probably thought I was wasting my time on an insoluble puzzle. But I trusted the silence. I trusted that my mind was working even when I couldn't see the results, like roots growing beneath the soil before the plant emerges. This is what I want you to understand. Your mind has its own rhythm, its own pace of development. It cannot be rushed. It cannot be forced. Just as you cannot make a seed grow faster by pulling on the shoot, you cannot accelerate genuine understanding by cramming more information into your head or seeking more advice from more sources. Quality over quantity. Always. One good book, thoroughly absorbed, is worth more than 100 books skimmed. One profound conversation is worth more than 1,000 superficial exchanges. 1 hour of deep, undisturbed thought is worth more than a week of distracted mental wandering. But our world doesn't reward depth anymore. It rewards speed, volume, visibility. It rewards those who can produce quickly, Respond instantly. Perform constantly. I'm telling you, resist this. Protect your inner world with the same fierce determination you would use to protect anything precious. Because it is precious. It's the only place where real thinking happens, where real creativity emerges, where you can become truly yourself. And here's what nobody tells you. The more you cultivate this inner space, the less you'll need from the outer world. Not because you become isolated or disconnected, but because you become complete. You discover that the validation you were seeking outside yourself was already available within. The answers you thought you needed from experts were already forming in your own understanding. This doesn't mean you never seek advice or never learn from others. It means you do so from a position of strength, not desperate need. When I was developing the theory of relativity, I didn't attend conferences begging for validation. I didn't send telegrams asking if my ideas were worthwhile. I worked through the mathematics, trusted the elegance of the equations, and knew deep in my bones that I was onto something profound. The validation came later, yes, but it came because the work was solid, not because I had performed my desperation convincingly enough. You've been taught to seek permission for your own thoughts, to apologize before speaking, to preface your insights with, "I might be wrong, but," or "This is probably stupid." But these aren't humility. They're habits of self-betrayal, learned responses from a world that profits when you doubt yourself. True confidence whispers. Insecurity shouts. The person who truly knows doesn't need to convince you. They simply present what they've discovered and let it speak. Meanwhile, the charlatan wraps empty claims in impressive vocabulary, desperately hoping you won't notice there's nothing underneath. I see you nodding along to ideas that don't quite sit right with you, afraid that disagreement will expose you as ignorant. But intellectual courage means saying, "I don't understand," or "I see it differently," even when everyone else is nodding. Especially when everyone else is nodding. Group consensus is often just coordinated cowardice. The internet age has weaponized your uncertainty. Every question you have is answered by someone claiming absolute authority. Every doubt you express is met with a course to buy, a guru to follow, a system to implement. They've turned your natural curiosity into a monetizable weakness. But here's what they won't tell you. Expertise isn't the opposite of uncertainty. Real experts live in the questions. They know what they don't know. They change their minds when evidence demands it. The frauds are the ones who never admit confusion, never acknowledge complexity, never say, "I was wrong." You already possess the most sophisticated truth detection system ever created, your own capacity for critical thought. Not gut feeling dressed up as intuition, but genuine, rigorous examination. Does this claim have evidence? Does the logic hold? What are the incentives of the person speaking? What am I not being told? These questions are your birthright, not a skill set you need to purchase. And perhaps most importantly, ask yourself what makes you come alive. Not what looks good on paper, not what impresses strangers at dinner parties, not what your parents dreamed for you when you were 5 years old. What actually lights a fire in your chest when you wake up in the morning? I spent years working in a patent office. A patent office! Can you imagine? The great Einstein filing papers about other people's inventions. And you know what? Those were some of the most productive years of my life. Because I had time to think, because I wasn't performing for anyone, because I was free to chase the questions that genuinely fascinated me. The world will try to convince you that passion is a luxury, that practicality must come first, that you should master the safe path before exploring the terrain that calls to you. This is perhaps the cruelest lie of all, because time moves in only one direction, and a life spent climbing someone else's mountain is still a life spent climbing. When you finally reach the summit and realize it's the wrong peak, you cannot simply reclaim those years. I am not saying quit your job tomorrow and move to Bali to find yourself. I am saying pay attention to the moments when you feel most energized. Notice what you do when no one is keeping score. Observe which problems you return to even when no one asked you to solve them. These are clues, breadcrumbs leading you toward your actual path, not the one sketched out in someone else's blueprint. The most revolutionary act in a world optimized for conformity is to know yourself deeply, to understand your values, not as abstract concepts, but as lived priorities, to recognize the difference between what you want and what you have been taught to want. This requires stillness, reflection, the courage to sit with yourself long enough to hear your own voice beneath the chorus of external expectations. And yes, it requires the willingness to disappoint people, to say no to good opportunities in service of great ones, to risk being misunderstood by those who measure success in conventional units. But here is what I know with absolute certainty. You will never think your way into a meaningful life. You must live your way into it, one honest choice at a time, one authentic step after another, one moment of integrity compounded across decades. Because here's what I've learned through all these years of equations and contemplation. The universe doesn't care about your press releases. It doesn't applaud your public persona or validate your carefully crafted image. But it responds, how it responds to the quiet consistency of who you actually are when nobody's watching. Think about water carving through stone, not through force, not through announcement, just persistent, patient presence, drop after drop after drop. That's the power we're talking about here. That's the force that actually reshapes reality. I've watched brilliant minds destroy themselves trying to maintain facades they thought would impress the world. I've seen talented people exhaust their creative energy managing perceptions instead of pursuing truth. And I've witnessed ordinary individuals accomplish extraordinary things simply because they stopped performing and started being. The mathematics of authenticity are elegant in their simplicity. Energy spent on pretense is energy unavailable for purpose. Every calorie burned maintaining a false self is a calorie stolen from your actual work, your real relationships, your genuine contribution. So here's my final equation for you, and it's perhaps the most important one I can offer. Let I equal integrity your authentic self, unchanged by observation. Let T equal time the continuous thread of your existence. Let C equal consistency, your willingness to remain yourself across all contexts. Impact equals I multiplied by T multiplied by C. Impact equals I times T times C. Your legacy, your influence, your actual mark on this world, it's the product of bringing your whole self to every moment, sustained across time, maintained with unwavering consistency. Not your highlight reel, not your greatest hits, not the version of you that photographs well, your whole self, your contradictions and certainties, your questions and your convictions, your doubts and your determination. This is the relativity that matters most. You are both utterly insignificant and infinitely important, a brief spark in cosmic darkness, and yet capable of adding light that wasn't there before. Small enough to slip through unseen, and significant enough to shift trajectories.